And hi everyone, I'm Claire. I'm a part of the product team at Juniper, and I used to be part of the product team at Apstra. So it has been quite a while for me. And I'm very excited about this session. It's about two new features that we are introducing in the coming Apstra release. And I'm going to talk about them briefly. I have 2 slides, one for each feature, and I'm going to jump right into a demo, which I think is more exciting than talking about slides or on slides. So let's do this. So the first feature that we are introducing soon is called tags. The best definition I could come up with is it's a first-class citizen metadata. It's just the capability to augment information about objects in a graph database that we don't have specific fields for. And it's used in many different products, in many different applications that you probably use every day in your life. But what's important is that is what we use it for and what we believe, how we believe it will benefit Apstra users. And so this is what I will try to demonstrate. We have enabled the concept of tags for 2 types of objects, nodes and links. Nodes are any EOS managed switch that you have in your fabric, but they are also any devices that are attached to the fabric, whether they are firewall or external routers or hosts. You can now tag, or we have enabled the capability for user to tag those objects with whatever they want. And we'll see why it's extremely powerful. And we call it first-class citizen because it's not just an API concept. It's not just about enabling metadata use case for external application and integration. It's the user that is going to manage tags, and we're going to do a lot of things in the GUI. We have enabled a lot of functions that rotate around tags, and I'm going to show like what it means. I'm going to show what are the workflow, data operation workflow that we think is going to benefit from tags. The second feature that I'm going to talk about is called connectivity template. It's a weird name, but basically it's providing a better mechanism or new mechanism for our end user to provision the connectivity towards whatever they have attached to the fabric, whether they are hypervisors running ESXi and NS60 edges, or whether they are firewall or load balancer stuff. Those things need to get connected to networks that the fabric manage. And we found we believe a better way to help the end user provision those connectivity. And the high-level concept is that we allow pre-packaging of connectivity requirement in a template, and so that the user can define the connectivity requirement for a group of applications one time, and then reuse the template across all the interfaces that are connected to the same type of host the template was built for. When I say connectivity requirements, I'm talking about a very specific set of things. I'm talking about VLAN, VXLAN membership definition. I'm talking also about templatizing BGP peering and routing policies. In the demo, I'm going to focus on the workflow that can be used for templatizing VN connectivity, because that's the most repetitive operation that people or customers do in the data center, versus establishing a BGP peering session with the external router is more like a one-time thing. But I just want to highlight that those templates are used across multiple type of networking concepts. So let's jump right into the demo part, and we can make this interactive. Please let me know if you have any questions while I do the demo. I'll be very happy to hear other voices while I'm presenting. So this is the GUI. It hasn't changed much. You should be familiar with it if you have seen other presentations. So what I have here is I have a data center that has already been deployed. That's my starting point. It's a decent sized data center. It has 160 servers attached to it and 16 racks. So it's pretty big. What I want to So what I want to show is I'm starting with a data center whereby the fabric has been configured. I have a running BGP EVPN fabric, and I have a bunch of already connected servers, hypervisors, firewall attached to it. So as a network operator, the next things I need to do, and actually I need to do it by tomorrow, is providing connectivity to those 160 devices attached to the fabric. So the first thing that I'm going to figure out is, okay, what are the different type of hosts that I have and what connectivity do they need? So I have already talked to my DevOps team, and I already figured out that the type of hosts that are going to be attached to it. And I have basically, a handful of applications. I have some hosts that are going to run clients, and they're going to require certain type of connectivity. I have a group of firewall that are going to be deployed a bit everywhere in the fabric that are going to help securing the traffic between certain VN. I have my external routers that are going to provide external connectivity for everything inside my fabric. I have servers, and I have storage and hypervisors. Great. So the first applicability that we see here of tags is that I was able to use tags to basically group all the nodes and the hosts that are attached to my fabric based on the type of connectivity that they need. So I've already went ahead and identified and tagged all my client nodes with the tag clients. So now I know exactly where my clients are. I don't have to start looking for the host IP address or host names to understand that this is a host that is of part of my client's group and that needs the client's connectivity. So the next step for me is to actually go and provision connectivity for those different hosts and services. So I've already went ahead and created a bunch of virtual networks based on the requirement that I received from my application team. So for example, all my clients are going to be connected over an overlay clients network called clients VN1. My servers are going to be all connected to servers VN1. My firewall is going to have a leg in both the client's VN and the server VN, and he's going to be basically the gateway for the client to server traffic and secure that traffic. And then my hypervisors are going to have to be connected to 3 different networks: hypervisors, network, management, and storage. So, okay, I have all the requirements written down. I have used tags to identify the nodes in my fabric and group them and classify them based on network requirements. Now, I'm going to demonstrate how easy it is going to be to do the provisioning for all of those things, 160 devices, in a couple of clicks. So this is where I introducing the concept of...
Hey, Claire.
Yes?
Sorry to interrupt. Before you show us that, I just have kind of maybe a more general question about tags in general, because I see Juniper's done a good job of this across some other products as well, and some other vendors are doing this too, which I see the power of tags, but I also worry about the human factor in managing tags, right? I mean, in a lot of networks I work on, device names, right, host names, interface names, like policy names, just we can't seem to keep any of the basics straight. So I wonder if there's anything you've thought about it as far as like tag sprawl or tag effectiveness in that region.
Yeah, I did think about it a lot because I use Jira a lot as a product manager, and there is a concept of labels in Jira that I love to use and abuse because it allows me to process new feature requests more easily because I can categorize them using labels and I can be like, oh, okay, all those new feature for IBA, I'm going to label them IBA, and next time I need to do a prioritization for the IBA product, I'll go and use that a query against the IBA label, and I love it. I also have the same sometimes issue that as I work with other people want to use the label IBA and they use the label IBA dash, I'm making things up. And so for me, there are cases where manual using labels for your own process as an individual is super powerful. But I think that if you want to establish a process for a team using labels, you better have an automatization process to manage those things. And this is where, consuming and managing tags through API, I think is probably a better way to do your tags management if it's something that you're going to rely on a lot and in your day-to operation. So I think we need both. We need to make tags first-class citizen in the GUI and allow users that are very meticulous with their work and they have maybe smaller data center to do the tags management manually. And then for other bigger, more critical tasks, automate it, use API to do it. That's my opinion.
Thank you.
So to go back to the demo, so basically here I want to build connectivity templates for the different type of hosts that are attached to the fabric. And so the first type of host are my client host, and they need connection to the client VN1. So I went a bit fast here, but I've clicked on the little icon above the virtual network list, and that pops up a new window here to create the connectivity templates. I'm going to call it client CT for connectivity templates. I can add a user-friendly description. We think that could be useful for documenting why you created this template and what it is used for. So I like to use it to describe the type of connectivity it provides and for who. So I would say like this is to be used for all client hosts and provide access to VN1, And because I selected client VN1, the definition of my template is actually basically the application of the VN to whatever endpoint I will select later on. I can choose my VN to be, when it's applied, to be applied as on a tagged interface or untagged interface here, using those options. I'm using untagged here. And I'm going to go ahead and create it. And I'm going to quickly do the same for my other application needs. So for the servers, I'm going to create also a server CT for all my server hosts. And I can choose tagged or untagged. So a lot of AOS is full of like validation, whether they're backend or front end. If you try to, for example, if you try to select multiple networks that are untagged, we're going to flag that as an error because it violates a networking principle. We try to really make things such that the user cannot shoot themselves in the foot as much as possible. So every networking rule that we know, we have implemented them, so it becomes a validation when you try to do things with templates.
I was going to ask back there on the tagged virtual networks. I'm assuming that supports more than one, but can you also just specify all, or what are the kind of? Okay, sweet.
So let's see, for example, the next example here, I want to connect, my firewall is going to need connection to the client and server VN. So I'm selecting two virtual networks. I click on the icon. I say firewall CT. I hope that's what you meant. And here you see, I've pre-populated the tagged virtual network with two VNs. I can add as many VNs as I want in the tagged virtual networks list. I can only have one untagged virtual network. And the last application that I want to that I need connectivity template for is my hypervisor. And my hypervisor is going to need to be connected to my hypervisor network, management and storage. You can say it's for ESXi, kube, or Docker. So now that I've created my template, I'm going to move over to my connectivity templates tabs, and I see that all the templates have been created here. I can also create template directly from that tab here, and I'll maybe show that a little bit later. So the last step of the process is basically to assign or apply those templates to all the interfaces that are facing my clients, apply these templates to the firewall facing interface, etc., etc. So the allocation is done like this. You click on the assign button next to the template. And here you're presented with the exhaustive list of interfaces that you have in your fabric. which is not very convenient if you want to only apply this template to a subset of interfaces, and specifically the one that are facing your client. And this is where tags becomes handy. You can filter out the pod interface by rack and leaf label and other stuff, but most importantly, you can filter them out by tags. So if you apply this query filter, now I'm only being shown the interfaces of my fabric that are client facing, and I can use the little wheel to do a bulk selection of all the client facing interface. I click on assign, and that basically perform the action to add all the client facing interface into all the VNs that are defined in my template, tagged or untagged, based on whether I use my network are in the tagged VN list or untagged VN list.
Is there a way to specify that this, profile or template rather should just apply to everything that has this tag?
It's not automatically done. So we thought about that. We went back and forth a little bit to see, do we really want to automate that? Right now, we don't want to, and we are waiting for customers to start using the feature to figure out whether they would want us to do that in the future. So as you add and remove tags, there is a rule in the system elsewhere that says, everything tagged with clients should have the client CT applied to it. It's a step that some people like and others don't. So it could be something we do as the next step for this feature, but right now it's not how it works.
So I had a quick question, Claire. In regards to like zero trust configurations with clients where you don't actually know what network you want them to join because you don't know what they are yet, have you guys thought about where tags fit in or don't fit in for that? Because you're not going to know what they are until they 802.1x in and actually auth, and then you drop them on whatever is the appropriate network. Are you going to retag? I think that's where Chris is probably going, right? Because as it comes in as a device, then you drop them in appropriate VLAN, VNI map, right? And then you're going to want a tag applied to them so that you can actually, is there any workflow that you guys have thought about around that side of it?
So in that workflow, can you explain me the workflow again?
Yeah, so if it's zero trust and you have someone coming in and plugging in, you're not going to know what network or VLAN to drop them on until they do their 802.1x auth, right? And then at that point, you're going to have a VLAN and a VNI that's attached.
It's a very campus, it's a very campus focused use case. So I think we would have to look at that as well. But I guess we're going to have to, there's a lot of place for integration here, right? So here it's all manual, but everything I'm doing here is exposed through API. So I think, looking at this type of use case you have where it's dynamic allocation of VN, you probably need to integrate, you want to probably build an integration with the system that is doing the VLAN allocation for that use case.
In that case, just have it do an API call and then go ahead and apply.
Here's like the first building block. The concepts, we introduce like new concepts, and I think those concepts are very powerful. Right now, it's all like basically manual. We don't have built-in integration yet that are leveraging those tags and CTs, but that's the next step we are going to take. Yeah, in terms of what do you have on that view? CT list, once you have assigned a CT to endpoints, you can actually see in the status how many endpoints have this template applied onto. You can also use the application view to find out what interface have what list of templates assigned to them. So I'm going to just go ahead and finish up the allocation of my other templates. So it's basically going through the same workflow. Here I have 4 firewalls, so I'm going to apply my template to all the firewall facing interface. Hypervisors, let's see how many hypervisors I have. Oops. Okay, and finally my servers. Oh, yeah.
And while that's loading there, does Apstra have the ability to actually integrate with the hypervisor itself to then, let's say I, configured my hypervisor connectivity template to include, n number of VNs. So then I want to configure my virtual distributed switch, maybe if it's VMware, to also support those tags. Is that something that's supported or thought about?
Not yet, but I'm saying yet because that's, again, we are integrating with NSXT managers and vSphere. Right now, we are we are pulling information into AOS database from those systems, and we are just using that to solve visibility issue and troubleshooting problems in terms of configuration mismatch between the fabric and the virtual infrastructure. But we haven't leveraged that completely yet to solve. We have one workflow to actually that is semi-automated, whereby if we do detect a misconfiguration between the fabric and the hypervisor from this integration we have with NSXT and vSphere, then we have a semi-automated workflow whereby we would automatically, by user action, automatically create the connectivity requirements on the fabric side to solve that issue. And Josh is going to talk about that in the presentation about NSXT. So we have a semi-automated workflow for NSXT and vSphere, but we haven't extended that workflow beyond that. And now that we have tags, I think we will. So I'm basically done with the provisioning of my networks for all of those devices. And this is something I'm doing on the stage environment. So no config has been pushed down to devices yet. I think you're familiar with our concept, the abstract concept of staged environment versus active environment. We allow user for any changes they want to make to first review them and validate them before they commit to them. So for the uncommitted tab, I'm given the opportunity to review my changes, and I'm happy with it. I can click commit, and I can name my commit for historical documentation. So the revision here is like provisioning of VNs for all clients, servers, firewall, and hypervisor. I'm going to commit that. And that's, yes, the other thing that I want to demonstrate is, okay, I've done that one time now. What happens if tomorrow my DevOps team wants me to give all the client devices access to the storage network? Well, instead of going to the VN or template and having to allocate a new template to all the client-facing interface, what you can do is you can reuse a template, client CT, you can edit it and add the storage network into the list of VN of the template. So you could do this. Whoops, no, I don't want to see anything. So you can add storage in the list of VN in your template, and by doing that action, it's going to add all the client service interface or all the application point of the template into the storage VN. The other cool thing is that you can, if you want to provide connectivity to another VN, to a subset of clients, not all of them, you can actually stack multiple templates next to each other on the same interface. AOS is going to validate that you're not doing anything stupid in terms of connectivity. It's going to verify that you're not trying to allocate twice the same VN or allocate an untagged interface to two different VNs and so forth. But you can, if I wanted to give all the clients storage access, I could just take the storage VN here, create a dedicated template for it. Connectivity templates, storage CT. I'm just going to verify that. Yeah. I'm going to tag it because I already have an untagged VN for my client interfaces. And I can then assign it. I can look at all the application points that are client facing. I can see that I already have a template assigned to all those client interfaces, but I can now also assign another template that is storage to like a subset of clients. I already have a VN storage configured on interface. So AOS is telling me that I have already assigned the storage VN in there. So I cannot do this operation, but I think you understand this workflow. So that's what I wanted to demonstrate for the connectivity templates. Now I want to talk a bit more about tags. So as I told you earlier, I already had manually tagged my devices and used tags to express and group my devices that need the same type of connectivity. So if I go under the catalog and tag tab, it helps me first of all understand, how many nodes of what type I have, but it also gives me a direct link to those nodes if I want more information about the nodes itself and other properties of the node. We have a global search here that allows you to search for any type of objects that are tagged with certain tags, whether they are links or nodes. And most importantly, we have introduced the concept of tags in the context of analytics. And I'm going to explain what that means through a little story. So I'm going to, first of all, revert all this, bring back the state of my data center with only committed changes. So I'm going to pretend I'm breaking something in the network. I'm going to bring one of my storage interface down. I'm going to use a little cheat script for that. And I'm going to see how is AOS Apstra, showing me what is Apstra telling me about this anomaly? How is it presented to me? So I'm just going to wait a couple of seconds for this anomaly to pop up. So here I see an interface anomaly. So I know that one interface that is supposed to be up in my fabric or towards my host is actually down. If I click on the anomaly, it shows me the name of the node and the interface that is down and so forth, which is pretty good. You can also in the active view see the node down from a topology perspective and drill down to the interface level like this. And then you can actually see which system it is impacted by basically clicking on the remote system that it's linked to this interface. And there I can see that it's a storage that's facing interface. So adding tags here helps me prioritize maybe the processing of this issue because I can see that, it's an interface to our storage and I need storage the business critical application or service. So it's already helpful, but what would be more helpful is that the dashboard directly here tells me that I have a storage, I have an anomaly that is impacting my storage. And we actually have that now. So you can use, the way it works is you can use IBA probes to build a network probe or questions about a specific set of nodes based on tags. So here I've built a probe. I've instantiated an IBA probe that is pre-built into Apstra that monitors flapping of interfaces. But instead of monitoring the flapping of all of my interface, I just want to have a dashboard that tells me whether I have flapping interface towards the storage. So that was very easy for me to do because I know that all my storage are tagged with the label storage. So I've updated the probe to only query the nodes and filter out the nodes that are tagged with storage. And that way I only see the the leaves that have interfaces connected to storage. So now if I, instead of flapping the link, so I'm going to bring my link back up. And I'm going to start flapping it. And I want to show you how it would look like in the monitoring dashboard, in the new one. It's going to take a couple of seconds for it to be refreshed, to be, there you go. So here, instead of having an anomaly that is about an interface, I have an anomaly that is impacting my storage. And I know that because that probe has been built for the storage tagged interface. If I would add a new storage server tomorrow in my fabric and tag it with the label storage, that will be immediately updating the result of that probe and add the new leaf or new leaf interface into that analytic probes.
So from an API point of view, can I ask AOS by the API, tell me which of my storage systems are experiencing flapping? So the result that comes back is only that second item, so that I can, kind of get that information, quickly through an API. Because I can imagine, using this kind of a feature across a very large set of different interface roles or connection type roles. And then I just want to know, what's wrong right now, and quickly get that information through the API.
Right. Yes. So yes, you can. And actually, it's basically monitoring the anomaly, not the whole table results. And that you can do through API, yes.
Cool.
We actually have also a streaming mechanism for anomalies only.